Welcome to the comprehensive guide for the neat material layering system in Unreal Engine 5. We'll begin by walking through the initial setup for a neat MLS material. Afterward, we'll dive into the fundamentals of the ML Basemaster material, which serves as the cornerstone for creating intricate and dynamic material layers. Following that, we'll explore how to use MLB Blendmaster to combine multiple materials in procedural ways. Lastly, we'll showcase some examples and share useful tricks and tips to help you master the neat material layering system and elevate your Unreal Engine 5 projects. Let's get started. Start by creating an instance of MT Layermaster in your Unreal Engine project. On its own, it can seem very simple, but this serves as a container for managing material layers. In the Layer Parameters panel of your Layermaster instance, set your base layer to the latest version of ML Basemaster, which in our case is ML Basemaster v3. This base layer establishes the primary material properties. Add additional material layers as needed, ensuring each layer's layer asset is set to the desired material. While ML Basemaster offers powerful controls, you're not limited to using it exclusively. It's crucial to set the blend asset of your Layermaster instance to MLB Blendmaster. This ensures proper handling of blending for all used materials, regardless of their complexity. Each layer within the Layer Parameter panel functions as its own instance within the created Layermaster instance. If you've customized a layer and want to reuse it elsewhere, use the Save Child button to export that layer as its own instance for easy reusability. Texture Coordinate UV. In this section, we'll manipulate texture coordinates for precise control over texture mapping. First, we have TexGauge UV channel switch. This node allows us to change the UV channel, offering flexibility in texture mapping. In the current implementation, only channels 0, 1, and 2 are available. Next, we can adjust the scale and offset of the UVs independently. To spin our material, we can use TexGauge UV Rotate. This may be a niche issue, but if you need to tile across mesh seams and want to retain texture seamlessness when rotating the texture, enabling B-Tile Safe Rotation will snap the texture in 45-degree increments to preserve seamlessness. Smaller degrees of rotation are possible, but the scale and aspect ratio distortions that arise make it not viable. Triplanar UV. Triplanar UVs provide an efficient way to apply textures seamlessly across different surfaces without relying on UVs. By enabling B-Triplanar, we activate this feature. We can choose between world space or local space projection using B-Triplanar world space/local space. If you're using this on skeletal meshes, then local space is required. Various parameters like Mesh Scale Size Influence, Mesh Scale Projection Influence, and Mesh Scale Normal Influence allow us to take the size and scale of the mesh into account when projecting textures. Here we can adjust the overall scale of the triplanar texture, and we can adjust the edge blending amount between the projection regions. For precise control over each X, Y, and Z axis, BXYZ independent control enables independent scaling, offsetting, and rotating. Hex Tiling UV. Hex tiling UVs introduce randomness to texture tiling, adding natural variation to surfaces. Activate B-Hex tiling to utilize this feature. Fine-tune the randomized scale and rotation with Hex Tile Scale Range Minimum, Hex Tile Scale Range Maximum, and Hex Tile Rotation. Adjust the blending area between tiles using hex tile contrast. Hex tiling can be used in conjunction with either TexGorge UVs or triplanar UVs. But when using them with triplanar UVs, be aware that this can cause your material to become expensive, so use wisely. PBR channels. PBR channels are crucial for achieving realistic material properties. Enable or disable channels like albedo, AO/displacement, roughness, metallic, normals, emissive, and opacity as needed. Be mindful of channel interactions, especially between opacity and emissive, as they both occupy the A channel of the albedo texture. Albedo. Control albedo properties using texture maps or solid colors. Fine-tune hue, saturation, and value with a LBHSV hue, ALBHSV saturation, and a LBHSV value. B. Override ALB color switches between using a texture and a solid color. ORM/DRM ORM/DRM textures influence AO displacement, roughness, and metallic properties. Toggle between ORM and DREM textures using B-switch ORM/DREM. Customize AO/displacement, roughness, and metallic with override options and contrast controls. Contrast range minimum and maximum are used quite often for many different parameters, so keep in mind that it controls sharpness or softness of any given texture or gradient, as well as the ability to invert the colors. Normal. Textures for normal mapping can be adjusted for strength and detail. B-detail, normal and B-nano-normal enable secondary and tertiary normal mapping layers. Fine-tune the strength and fade off of these layers for intricate surface details. Emissive. Emissive properties can be controlled using textures or solid colors. Similar to albedo, we can override with a solid color using B-override emissive color. Adjust the color and strength of emissive lighting using emissive color and emissive strength. Opacity. Opacity settings are crucial for materials using the transparency shading model. Override opacity with a flat value or control the contrast using opacity value, opacity contrast range minimum, and opacity contrast range maximum. B-Dither provides a cheaper alternative to true transparent materials. Just make sure to use the mask shading model instead. MLB Blend Master. UV settings. UV settings for text-scored UVs and triplanar UVs remain the same as they did in ML Base Master, though hex tiling has been disabled here for performance reasons. In the MLB Blend Master material, these settings are mostly just used for adjusting mask textures or distorting the edges. Blend layers. In MLB Blend Master, you can blend various channels between top and bottom layers to achieve complex material effects. Settings such as B-Blend Albedo, B-Blend Ambient Occlusion, B-Blend Displacement, B-Blend Roughness, B-Blend Metallic, B-Blend Nend Normal, B-Blend Me Emissive, and B-Blend Opacity allow you to control the blending of different material properties. Ensure to configure the appropriate blend settings based on your desired material outcome, and discard unused channels when possible to save on performance. Mask Manager. The Mask Manager in MLB Blend Master offers extensive control over blending masks to achieve intricate material effects. While default blend value acts as a simple blend between the top and bottom layers, you can utilize options to create custom blending masks based on various inputs such as normals, vertex colors, textures, and more. Experiment with additional settings like B-Edge Color or BMM Generate Normals to add a color tint or additional normal details at the edge of your created mask. Mask Manager. Noise Distort Edges. This section is only used in masks created by ambient occlusion / edgeware and vertex color to distort the edges and create more interesting masks. You can either use procedural noise or use a text chord / triplanar UV texture to distort the edges. When using a texture, you can change the texture, isolate a channel, and adjust the contrast range. Mask Manager. AO / edgeware distance fields. Enhance your material blending effects with AO and edgeware distance fields. Configure settings such as B low quality AO / edgeware and B switch AO / edgeware to control the quality and type of distance field effects. Fine-tune parameters like AO / edgeware contrast range minimum and maximum to control the fall-off and AO / edgeware noise strength to control the influence that noise edge distort has on the final result of the mask. This effect can be very intensive, so save beforehand and consider enabling this last. Mask Manager. Normal Direction. Use the normal direction to create directional masks based on normal planes, bound either locally or globally. Use the channel mask and rotation sliders to isolate and get your desired direction mask. Use TX Normal Will toggle between texture-based normals and mesh-based normals. Mask Manager. Vertex Colors. Create a mask from the RG or B channels of your selected mesh's vertex colors. Adjust the contrast and noise strength as needed. Mask Manager. Texture Mask. Create a mask from a texture with text-scored UVs or try planar UVs. Mask Manager. Height Mix. Blend displacement textures between layers using the Height Mix mask. Fine-tune parameters like height, mix top-bottom mix to adjust the blending ratio between top and bottom layer displacement textures, or just use the bottom layer's displacement map. Example material: dusty, cracked painted metal. To wrap everything up, let's create a neat MLS material from start to finish.